Ever wonder how we went from armies of workers swinging scythes to one farmer harvesting hundreds of acres in a day? The combine header made it possible. This cutting-edge attachment transformed grain harvesting from backbreaking manual labor into the mechanized marvel we know today. Let's dive into the incredible journey of how this revolutionary technology reshaped American agriculture. 7. The birth of mechanized harvesting. Before we had combine headers as we know them, grain harvesting was a community affair. Picture this: dozens of men moving through fields with cradle scythes, women and children following behind to gather and bind sheaves. It took 20 man-hours to harvest and thresh a single acre of wheat. That's 2.5 days of work for one person per acre. The first breakthrough came in 1831 when Cyrus McCormick patented his mechanical reaper in Virginia. This horse-drawn contraption had a cutting bar with triangular knives that moved back and forth, slicing through grain stalks like a barber's scissors on steroids. The cut grain fell onto a platform where a man with a rake pushed it off in piles. It wasn't pretty, but it cut harvesting time by more than half. By the 1870s, the reaper evolved into the harvester binder. These machines not only cut the grain, but also automatically tied it into bundles using twine. The Deering Harvester Company and McCormick Harvesting Machine Company battled it out for market dominance, each claiming their machine was superior. Farmers loved the competition. It drove prices down and innovation up. The real game changer came in 1885 when the first combine harvester appeared in California's San Joaquin Valley. These behemoths were pulled by teams of 20 to 40 horses or mules and required a crew of 6 men to operate. The header, that crucial front attachment, was essentially a wide cutting platform that could be raised or lowered to match crop height. It featured a revolving reel with wooden slats that pushed the grain stalks against the cutter bar, then swept the cut grain onto a canvas conveyor that carried it into the threshing mechanism. These early headers were crude but effective. The cutting width ranged around 15 feet, absolutely massive for the time. The reel was adjustable for different crop conditions, moved forward for lodged, fallen grain, back for standing grain. Farmers quickly learned that header adjustments could make or break their harvest. Too high and you'd leave money in the field, too low and you'd pick up dirt and rocks that could damage the thresher. By 1900, combine headers had evolved significantly. Manufacturers like Holt Manufacturing Company, later Caterpillar, and Best Manufacturing were producing headers with improved knife guards, better reel designs, and stronger frames. The transition from animal power to steam engines was beginning, and headers needed to be redesigned to handle the increased speed and capacity. This period marked the true beginning of the modern combine header, no longer just a cutting attachment, but an engineered system designed to efficiently feed grain into increasingly sophisticated threshing mechanisms. Before we move on to the next one in the list, I'd like to ask you a small favor. If you're enjoying this content so far, please take a second to like this video and subscribe to the channel. Over 98% of you watch these videos without subscribing. Imagine what we could accomplish if everyone subscribed. It costs you nothing, but it makes a huge difference to us. Thanks to all of you who do. 6. The gasoline revolution and mass production. The 1920s brought the gasoline tractor, and with it, a complete reimagining of the combine header. Massey Harris led the charge with their number 21 self-propelled combine in 1938, featuring a 12-foot header that could be hydraulically raised and lowered from the operator's seat. This was remarkable, no more jumping off to manually crank adjustments while your neighbors watched you struggle in the mud. John Deere wasn't about to be left in the dust. Their Model 55 combine, introduced in 1947, featured their new bat reel design with spring-tined fingers. Springs and pivoting sections allowed the header to follow ground contours, reducing grain loss on uneven terrain. Farmers called it ingenious. The header seemed to sense every bump and dip, maintaining the perfect cutting height with minimal adjustment. Case took a different approach with their straight-through design. Instead of the grain making multiple turns inside the header, their auger system moved it directly from the cutter bar to the feeder house. This reduced grain damage and increased capacity by nearly 25%. The engineering was brilliant in its simplicity. Fewer moving parts meant less maintenance and fewer breakdowns during those critical harvest days. The standout innovation of this era was the power takeoff driven header. International Harvester pioneered quick coupling mechanisms that allowed farmers to switch between different header types in minutes rather than hours. Need to switch from wheat to barley? No problem. Pop off the grain platform, slide on the pickup reel, and you're back in business. This flexibility transformed farming economics. One combine could now efficiently harvest multiple crops. Manufacturing exploded during World War II as headers were deemed essential for food production. The War Production Board allocated steel specifically for header construction, recognizing that efficient harvesting was crucial for feeding both troops and civilians. Alice Chalmers alone produced over 15,000 headers between 1942 and 1945, many featuring innovations born from wartime engineering advances. The post-war boom saw headers grow wider and more sophisticated. The standard 10-foot header of 1940 became 12, then 14, then 16 feet by decade's end. Mechanical reel speed adjustment appeared in 1948, allowing operators to match reel speed to ground speed more precisely. This prevented the reel from throwing grain over the back, causing loss, or moving too slowly, causing plugging. Material science played a huge role too. Chrome-plated cutter bars resisted wear 5 times longer than plain steel. Heat-treated knife sections stayed sharp through entire seasons. Ball bearings replaced bronze bushings in reel drives, reducing maintenance intervals from daily to weekly. These might seem like small improvements, but they added up to substantial gains in reliability and efficiency. By 1950, the modern header's DNA was fully formed. Every essential component we see today, adjustable reel, flexible cutter bar, cross auger, and mounting system, was present and refined. The American farmer could now harvest more grain in a day than his grandfather could in a month, and the header was the sharp edge of that transformation. 5. The cornhead revolution and crop specialization. The 1950s marked a pivotal shift in header technology when engineers finally cracked the code on mechanical corn harvesting. Before specialized corn heads, farmers either picked corn by hand, backbreaking work that limited acreage, or used modified grain headers that left substantial crop in the field. The introduction of the dedicated corn head changed American agriculture forever. Minneapolis Moline struck first in 1953 with their 2-row-mounted picker-sheller unit. It featured snapping rolls that grabbed the stalk and pulled it down while stationary stripper plates held the ear, popping it clean off. The gathered ears then traveled through husking beds, rotating rubber rollers that stripped away the husks. It was aggressive, effective, and incredibly efficient. Farmers who previously needed 20 workers to harvest corn could now do it alone. John Deere refined the concept with their 234 as a mounted picker, not a combine head. Deere's combine heads of the mid-1950s marked the shift to on-combine picking and shelling. Their innovation, gathering chains with extended lugs that positively controlled stalks from entry to snapping. Any farmer who's tried to harvest down corn knows this was nothing short of miraculous. The chains grip stalks firmly, ensuring clean ear removal even in severely lodged conditions, keeping losses minimal even when corn was nearly flat. International Harvester went bigger, literally. Their 1961 4-row corn head doubled harvesting capacity overnight. The engineering challenge was immense. How do you feed 4 rows of corn into a combine designed for 2? Their solution involved a wide cross auger and innovative feeder house design that evenly distributed the crop flow. Farmers initially skeptical about the width quickly became believers when they completed harvest in half the time. Meanwhile, soybean production was exploding across the Midwest, demanding its own specialized solution. The problem with soybeans? The pods grow just inches off the ground, and standard grain headers couldn't cut low enough without pushing dirt into the combine. Enter the flexible cutter bar header in 1962, developed by Hart Carter, later part of White Farm Equipment. The Flex Head's genius was its segmented cutter bar that could bend and flex to follow ground contours. Each 3-foot section floated independently on skid plates, maintaining a consistent cutting height even over rolling terrain. Full-width flexible headers could follow the ground like water, capturing valuable pods that rigid headers missed. Soybean yields immediately jumped 10-15% simply from reduced harvesting losses. And this era also saw the birth of specialized headers for emerging crops. Sunflower headers appeared with collection pans to catch falling seeds. Rice headers featured extra tall reels and reinforced frames for muddy conditions. Edible bean headers had gentle handling systems to prevent seed coat cracking. The header was no longer one size fits all, but precision engineered for maximum efficiency in specific crops. The economic impact was staggering. Corn production in Iowa alone jumped from 450 million bushels in 1950 to over 1 billion bushels by 1970, largely enabled by efficient mechanical harvesting. The corn head made the modern livestock industry possible. Without cheap, abundant corn for feed, we wouldn't have affordable beef, pork, or poultry. Similarly, the flex head enabled America to become the world's soybean powerhouse, fundamentally altering global protein markets. 4. The wide header race and hydraulic innovation. The 1970s triggered an arms race in header width. If 20 feet was good, wouldn't 30 feet be better? The go big or go home mentality swept through farm country like wildfire. But engineers quickly discovered that simply scaling up existing designs created catastrophic problems. Headers were breaking in half, reels were whipping like helicopter blades, and grain was piling up unevenly across the platform width. The solution came from an unexpected source: aerospace engineering. McDon Industries hired former aircraft designers who applied wing stress analysis to header frames. They discovered that traditional straight beams created stress concentration points that caused failures. Their answer? Truss-style frames with triangulated supports that distributed loads evenly. The resulting headers could span 30 feet without excessive flexing or stress fractures, even when fully loaded with crop. Hydraulic technology transformed header control during this period. Case IH introduced infinitely variable hydraulic reel speed control in 1975, using hydrostatic drives that could be adjusted instantly from the cab. No more stopping to change sprockets or adjust chain tension. Operators could fine-tune reel speed to match changing crop conditions immediately. In tangled wheat, speed it up. In fragile beans, slow it down. This single innovation reduced grain loss by an estimated 5% industry-wide. The automatic header height control competition began in earnest in 1978. Massey Ferguson's electronic stone guard used mechanical sensing fingers that triggered solenoid valves to maintain consistent cutting height. John Deere countered with their automatic header control system using electronic sensors and proportional hydraulic valves for smoother operation. International Harvester introduced their Hydra Touch system featuring dual sensors that maintain precise header position regardless of ground speed. But the real breakthrough was the Draper header's arrival in North America. Originally developed in Australia for harvesting rice, Draper headers replaced the traditional cross auger with canvas or rubber conveyor belts. Honeybee Manufacturing in Saskatchewan introduced the first commercial draper for small grains in 1983. The belts moved crops straight back in a smooth, continuous flow rather than the aggressive augering that could crack grain kernels. Drapers offered compelling advantages: 15% increase in capacity, significant reduction in grain loss in short crops, and the ability to handle bushy, tangled crops that plugged auger headers. The drawback? They cost substantially more than conventional headers and required different maintenance skills. Early adopters faced skepticism for spending premium prices. Those same farmers were vindicated when they finished harvest days ahead of their neighbors. The economic pressures of the 1980s farm crisis accelerated header adaptation. Farmers couldn't afford new combines but desperately needed increased efficiency. Header manufacturers responded with retrofit kits, hydraulic reel drives for mechanical reels, bolt-on automatic height controls, and header width extensions. A farmer could modernize his 1970 combine's capability for a fraction of replacement cost. Material technology advanced significantly too. Ultra-high molecular weight polyethylene skid shoes replaced steel, lasting entire seasons without replacement. Oil-impregnated bronze bushings eliminated daily greasing requirements. Improved metallurgy and knife sections maintained edges longer. These unglamorous improvements meant farmers spent less time on maintenance and more time harvesting, crucial for economic survival. By decade's end, 30-foot headers were standard, and 36-footers were emerging. The technology that seemed impossible in 1970 was now commonplace. But this was just the foundation for what was coming. 3. The precision agriculture era. The 1990s brought computers to the header, and nothing would ever be the same. John Deere shocked the industry in 1992 with their Green Star precision farming system, among the first GPS-integrated header controls. Satellites could now track the header's exact field position and automatically adjust cutting height based on topographical data. Operators went from constantly adjusting controls to simply steering while the header managed itself. Case IH responded with their advanced farming systems in 1996. Unlike simple reactive height control, their ultrasonic sensors could detect the crop canopy ahead and proactively adjust. The header would begin lifting before hitting a rise, then smoothly lower into depressions. It was like having an experienced operator's instincts built into the hydraulics. The Draper header evolution accelerated when McDon introduced the 972 Harvest header in 1998, a 36-foot Draper that redefined expectations. This wasn't just a wide header, it was technologically sophisticated. The split reel design with hydraulic drive allowed variable speed across the header width. Center feed design eliminated side feeding issues. At premium prices, it represented serious investment, but custom harvesters recognized the efficiency gains immediately. John Deere revolutionized row crop harvesting in 2000 with their 600 series corn heads featuring row sense technology. Mechanical feelers detected row position and automatically steered the combine. The operator literally didn't need to touch the steering wheel in standing corn. More importantly, the system maintained perfect row alignment even at unprecedented speeds. 7-8 miles per hour became feasible, where 4-5 miles per hour was once the maximum. Stripper headers appeared for small grains, using rotating drums with plastic fingers to strip grain heads from stalks, leaving straw standing. Shelbourne Reynolds headers from England could harvest wheat 40% faster than conventional headers while using less fuel. The standing stubble provided erosion control and moisture retention environmental benefits that earned adoption incentives in conservation programs. The soybean header competition intensified with pneumatic assistant systems. Prairie Company's air reel used high-velocity air to blow plants forward into the cutter bar, capturing pods that traditional reels missed. Precision Planting's vacuum systems literally sucked plants upright for cleaner cutting. Both systems could save 3-4 bushels per acre in challenging conditions, significant money at prevailing prices. Electronic monitoring reached new sophistication. Headers now featured sensors for shaft speeds, belt tension, hydraulic pressure, and bearing temperature. Onboard diagnostics could predict component failures before they occurred. Intelligent headers would automatically reduce speed when approaching capacity limits, then accelerate when conditions improved. The combine was becoming semi-autonomous, with the header as its primary sensing system. Yield monitoring transformed from curiosity to essential tool. Headers equipped with impact plates and optical sensors created real-time yield maps accurate to sub-meter precision. Farmers could finally quantify field variability down to individual drainage tiles or soil types. This data revolutionized everything from variable rate seeding to tile drainage planning to crop insurance claims. The economic impact was measurable. Average U.S. corn yields jumped from 134 bushels per acre in 1990 to 153 bushels by 2005, partially attributed to reduced harvesting losses from improved headers. Custom harvesters could now cover 801,000 acres per day reliably, making large-scale contract harvesting economically viable. The header had evolved from simple cutting implement to sophisticated data acquisition system. 2. The modern monster headers. The 2010 S witnessed headers growing to almost incomprehensible dimensions. McDon's 2011 introduction of the FD75 Flex Draper at 45 feet made previous wide headers look modest, but Midwest Manufacturing pushed boundaries in 2018 with their experimental 50-foot Draper prototype. That's wider than many building lots. Watching one unfold is mechanical choreography, hydraulic wings extend, belts tension, and suddenly you're harvesting a swath wider than a 4-lane road. These massive headers required fundamental engineering changes. Traditional mechanical drives couldn't handle the torque loads, so manufacturers switched to individual hydraulic motors for each functional section. New Holland's Verifeed headers featured 7 separate hydraulic circuits controlling different functions. The operator's station resembled mission control with displays monitoring every parameter imaginable. John Deere shifted the paradigm in 2015 with their 640 FD Hydroflex draper. This engineering marvel could flex 6 inches vertically across its entire width while maintaining consistent belt tracking. The float system was so responsive it could cut soybeans at ground level without soil ingestion, while simultaneously handling varying crop heights. Sensors every few feet monitored ground pressure and automatically adjusted hydraulic cylinders for optimal float characteristics. Artificial intelligence entered the header realm through CNH's 2017 harvest automation systems. Headers could now communicate with grain carts, trucks, and elevators, automatically optimizing harvest speed for logistics efficiency. If elevator lines were backing up, the header would reduce speed to prevent grain tank overflow. When capacity opened, it would automatically accelerate. The entire harvest became an orchestrated system managed by algorithms. The corn head reached new sophistication with Calmer's BT Chopper Stalk Devastator technology. Integrated chopping systems pulverized stalks into inch-long pieces, eliminating separate residue management passes. Geringhoff's Horizon Star featured independently floating row units that could handle 50-degree slopes. These weren't just headers anymore, they were complete crop processing systems. Folding corn heads became the ultimate efficiency tool. Dragatech's 16-row folding corn head could harvest 40 feet of corn, then fold to legal transport width in 60 seconds. The engineering required to fold thousands of pounds of steel while maintaining precise row unit alignment was extraordinary. Watching one fold is engineering ballet, a precisely sequenced hydraulic symphony. Smart technology reached unprecedented levels. Claas's CMOS auto header used stereoscopic cameras to map crops ahead and predictively adjust settings. It could identify lodged patches and adjust reel position before entering them. In corn, it detected missing plants and adjusted deck plate spacing automatically. The header was literally seeing, analyzing, and adapting. Alternative crop headers proliferated dramatically. Hemp headers emerged as industrial hemp production expanded. Specialized seed headers could harvest everything from grass seed to quinoa without loss. Biomass headers handled energy crops like switchgrass and willow. The customization became infinite. Farmers could essentially engineer headers for any harvestable crop. The economic realities are striking. A modern 45-foot draper represents $130,000 to $180,000 investment, but can harvest 2,000 plus acres daily under favorable conditions. That's what once required entire harvest crews, now accomplished by one operator monitoring tablet computers. When racing weather across 10,000-acre operations, the economics become compelling despite the staggering initial cost. 1. The future is here, autonomous, and beyond. CNH's 2024 autonomous concept vehicles take things further. Using LiDAR, radar, and multispectral cameras, they create real-time 3D crop models 30 feet ahead. The AI predicts optimal cutting patterns, automatically compensates for crop variability, and can identify and avoid obstacles autonomously. In testing, these systems achieve 98% harvesting efficiency, exceeding experienced human operators. The header essentially becomes the combine's brain, rather than just its cutting tool. Predictive maintenance has reached extraordinary sophistication. AGCO's Fuse Connected Services uses vibration analysis, thermal imaging, and acoustic signatures to predict component failures 1,5,200 operating hours in advance. The system automatically orders replacement parts and can schedule service during optimal weather windows. Progressive farmers report near zero unexpected header failures unimaginable just years ago. Electric headers are transitioning from concept to reality. Fendt E100 Vario with electric implements features all-electric headers with individual motors per function. No hydraulic fluid, no mechanical drives, just instant torque and infinite adjustability. Motors can reverse instantly for unplugging, adjust speeds in milliseconds, and operate nearly silently. Early adopters report 25% reduction in power consumption for equivalent capacity. Material science continues advancing rapidly. Carbon fiber reels weigh 40% less than steel while maintaining superior strength. Self-sharpening knife sections using diamond-like carbon coatings maintain edges for multiple seasons. Graphene-reinforced draper belts show minimal wear after thousands of hours. These materials carry premium prices but deliver through reduced downtime and extended service intervals. The cloud connectivity is transformative. Modern headers upload performance data continuously where machine learning algorithms analyze patterns across global fleets. If one header discovers optimal settings for specific conditions, every connected header worldwide can access that knowledge. It's collective intelligence on a planetary scale, millions of acres of experience concentrated into continuously evolving algorithms. Sustainability features are becoming mandatory. McDonald's latest drapers measure residue distribution patterns in real time, optimizing for soil health and carbon sequestration. Integrated seed retention systems prevent volunteer plants. Variable residue processing adjusts chopping intensity based on decomposition requirements. The header is becoming an environmental stewardship tool. Multi-crop adaptability has reached impressive flexibility. Several manufacturers offer transformer headers that reconfigure between crops in under 10 minutes using programmed adjustment sequences. Stored profiles for different crops and conditions eliminate setup delays. One header investment can effectively replace multiple specialized units, dramatically improving utilization rates. Looking ahead, the possibilities seem limitless. Researchers are developing headers with hyperspectral imaging for disease detection during harvest. Laser cutting systems that never require sharpening are in development. Swarm harvesting with coordinated autonomous units is being field tested. The next decade promises innovations that will make today's technology look primitive. The combine header's journey from simple cutting bar to AI-powered harvesting system represents one of agriculture's greatest triumphs. It's enabled feeding billions while using fewer resources and less labor than ever imagined. As global population approaches 10 billion, these mechanical marvels will continue evolving, ensuring humanity's most fundamental need, food, remains abundant and accessible. From those first horse-drawn platforms cutting grain at walking speed to today's autonomous monsters harvesting at highway speeds, the combine header has been the sharp edge of agricultural progress. It transformed farming from brutal manual labor into precision science. Next time you see a combine rolling through a field, take a moment to appreciate that header out front. It's not just cutting crops, it's harvesting the future. If you enjoyed this journey through harvesting history, smash that subscribe button and join us for more incredible stories of the machines that built modern agriculture. Until next time, keep your headers sharp and your grain bins full.